evening one and all. Shri Mahavidyalaya Shikshan Prasarak Mandals, Shri Kumarswami College Ausa welcomes all the honorable dignitaries and participants here on the virtual platform for the national webinar. The topic of today's national webinar is Understanding the Stars, HR diagram. The college, Shri Kumarswami College Ausa, has been running a long series of webinars, national and international. These covered numerous topics related with different fields. The theme of webinar series is Women Empowerment, Women Dignity and Environmental Conservation. The webinar series has been started on the occasion of the Golden Jubilee year of the institution. The objectives of the webinar series are to exchange knowledge, to enrich knowledge, and to have intellectual discussions among the participants so that we can get answers to questions and solutions to problems which can benefit and help the individuals, the society and the nation. The attempt of webinar series is going on very successfully and smoothly, and the cause behind it is the strong academic leadership of the chief organizer and chairperson of this webinar series, Honorable Principal Dr. M. Ambedkar sir, and moral support of the institution. In the beginning of this national webinar, I welcome Honorable Principal Dr. M. Ambedkar sir as the chairperson of this webinar. Today, I am very pleased to inform you that we have the Honorable Dignitary and Keynote Speaker, Dr. Rashmi Uniyal ma'am from Department of Physics, Government Degree College, Narendranagar, Tehri, Garhwal, Uttarakhand. She is going to enlighten us on the topic Understanding the Stars, HR diagram. On behalf of the organizing committee of webinar series, Shri Kumarswami College Ausa, I heartily welcome you ma'am as an invited speaker for this national webinar. I also welcome all honorable organizing committee members, including Vice Principal Dr. S.D. Misal sir, Junior College Supervisor Ravindra Karanje sir, MCVC Supervisor Praveen Umine sir, IQAC Coordinator Dr. Sanjay Kale sir, Dr. Anita Dhole ma'am, Dr. Sudhir Garar sir, Ambadas Khillare sir, Dr. Patwari sir and Dr. Wadkar sir. We all are here to hear the keynote speech by the honorable speaker. But if we listen the introduction of the today's chief guest and honorable speaker, we will have the pleasure. So I request Dr. Anita Dhole ma'am for the introduction of today's chief guest and resource person. Please ma'am, welcome.
Thank you sir. Good evening everyone. You are welcome to this grand national and international webinar series on occasion of Golden Jubilee year of the college. Shri Kumarswami Mahavidyalaya Ausa has organized a wonderful grand knowledge sharing webinar series with the aim of women empowerment and women dignity. So from pandemic days, the series is going on very systematically because of the hard efforts of the respected principal Dr. Ambedkar MM, all the resource persons and the punctual participants. I am very thankful to respected principal for giving me this opportunity to introduce the resource person on this virtual platform. Many special thanks goes to all the respected organizing committee members and big thanks to all the respected participants. Those are joining daily from all over India and abroad also, and they are making this series a very successful series. So it's my pleasure. I am here to introduce today's keynote speaker, Honorable Dr. Rashmi Uniyal ma'am, Department of Physics from Government Degree College, Narendranagar, Tehri, Garhwal, Uttarakhand. Title of speech is Understanding the Stars HR Diagram. Dr. Rashmi ma'am is working as Assistant Professor in Physics. She has completed MSc in Physics from HNBGU, Srinagar, Garhwal, and PhD from GKV, Haridwar. She got Women Scientist Excellence Award for work done in the field of education. She achieved Government Excellence Scholarship for postdoctoral position in Physics Institute, University of Zurich, Switzerland under Swiss. She has published a number of research papers on national and international level. She is visiting associate of Inter-University Center for Astronomy and Astrophysics. She got Young Scientist Award for Best Oral Presentation. She has international work experience in Department of Physics at University of Rome, Italy. For 1 month, she worked as a visiting scientist at University of Zurich at Switzerland. So, after this brief introduction, I would like to request today's keynote speaker, Honorable Dr. Rashmi ma'am, please start your presentation. Thank you. Welcome, ma'am.
Thank you so much, ma'am. First of all, I would like to thank the whole organizing team of this webinar series to make me a part of this program. Thank you so much for this nice introduction, and please let me know. I will share my presentation here. So, is this visible?
Yes, madam, yes.
So, very good evening to all of you. So, before actually starting the discussion on a very fundamental thing with which we all of us see every day in our life, first of all, I love to recite few lines of Harivansh Rai Bachchan ji. In one of his poem, he writes it like Shwet Akshar Prisht Kala तारकों की वर्णमाला पढ़ रही हैं एक जीवन का जटिल इतिहास आंखें देखती आकाश आंखें. So we all know that astronomy has been one of the oldest observational sciences, and looking out to the skies has been the initial step for understanding the fundamental problems such as the existence of our own universe and many more. So today I will be talking about various stellar properties, actually some of them, and one of the important tool for astronomers, typically known as Hertzsprung-Russell diagram. So let's start with asking the question that what are the stars? So stars are big balls of gases with fusion going on at the central region, and all of it held together by gravity. So if we compare with our own sun, there is a whole range of stars. They may be very massive, comparable to it, or very less massive than sun. Hence the method by which heat transfers from core, where originally it's being generated due to nuclear fusion, up to the outer atmosphere of a star also depends on their masses. So the stellar structure, as you can see in this slide, that stellar structure also varies with stellar mass. If one looks for a particular any of the star, however, the process of nuclear fusion is taking place at the core in every star. In sun-like stars, hydrogen is being synthesized to form helium. And this is that particular process in simplified format. This synthesis takes place in such a way that mass of resultant helium is smaller than its constituent masses. And amount of energy which is equivalent to this difference in mass, also known as mass defect, as we all are students of physics, so we hopefully we know this term, is actually the amount of energy given off due to this process and known as binding energy of the system. So it's essentially the energy source of star. If one looks at this particular image, which is crowded with several stars, what one directly infers is that there is a difference in their brightness and also there is a difference in their color. So for astronomers, when one talks about brightness, they measure it in terms of something called luminosity, which actually accounts for power output of any star. It can be measured for any specific wavelength or any wavelength range. So just to have a comparative views, as I already mentioned that skies have different sizes of stars. These are bigger as well as smaller than sun. Just to have a comparative picture, if one compares Sun to Sirius in middle third picture, we can see if one compares Sun to Sirius, which is the brightest star in sky after Sun, so Sun is smaller in size. And further we can see that there are more bigger and bigger stars are there. So there is a whole range of sizes of stars. So how one can understand star? One of the important tool for astronomers is known as HR diagram. What this HR diagram actually is, this diagram relates the observational properties of stars and typically luminosity and temperature of the star. Hence, HR diagram is a plot between luminosity, or you can say absolute brightness, which we will be briefly talking in this talk, of the star on y-axis versus temperature or spectral class of star on x-axis. So I will try to address these few issues here, that where are most of the stars situated in a typical HR diagram, then what a HR diagram tell us about, and finally how stars evolve. So if we try to infer that lives of stars can range from million to billions of years actually. Hence, if one assumes that I will like observe a star for it whole of its lifetime, it's actually impossible for a humankind to observe a whole life of any star directly. Hence, one needs physical laws to understand different stages of life of a star, or we can say to understand the stellar evolution. From theoretical viewpoint, the most important parameters which determine life of stars are its mass and chemical composition. While the observation says that absolute brightness or luminosity and temperature are the most important parameters which can be used as important tools to determine the stellar life or their evolution. So now how one can measure the brightness, or what are the different scales which astronomers used? In 19th century, astronomers devised various different tools which allowed them for the first time to make accurate and quantitative measurement of stellar brightness. Hence, first magnitude star, if one tags one star like it is a first magnitude star, it is roughly 100 times brighter than a sixth magnitude star. As this equation you can see here, if two stars are there and they have an intensity ratio of I2 by I1, so magnitude difference relates by this equation. So the intensity ratio of 1 by 100 gives the magnitude difference of +5, while the intensity ratio, if it is 100, then the magnitude difference is -5. So the brighter the star is, smaller is its magnitude. So let's take an example. Let's concentrate on the night sky, and different observed bright stars are there. let's take an example of Sirius that has an apparent magnitude of minus 1.44, and Betelgeuse, which is a red giant star in Orion Nebula. So that has an apparent magnitude of plus 0.45. So question is that what does it really tells about these two stars, this information? So a star may appear bright due to two main reasons. First, it may be intrinsically luminous, which would be the case if it is a powerful emitter of electromagnetic radiation. And second, it may be very close to the observer or very close to Earth. So, or both of these factors are there. So apparent magnitudes partly depend on the distance of star from observer, like the case of Sirius and Betelgeuse, which we discussed like just before. Sirius is very close to us, only 2.6 parsecs away, while Betelgeuse is about 160 parsec distant. Hence, the apparent magnitude alone is not sufficient to compare the stars because it is distance dependent. And when you talk like in cosmic scales, distances are very huge in terms of light years or so. So, another important scale for brightness measurement appears as the absolute magnitude, which is the magnitude of a star that the star would have if it were at a distance of 10 parsecs from Earth. And then we have this distance modulus equation by which we can know the magnitude and other things. So now if this absolute magnitude of a star is another way of describing luminosity. It is a measure of total amount of energy radiated by a star or any other celestial object per second. It is therefore the power output of a star. Further, if one measures it across all wavelengths, we term it as bolometric luminosity. Or luminosity in a specific wavelength can also be measured and used to measure the what we call color of a star. Now one can ask what properties determine the intrinsic power output or luminosity of a star. So there are basically two important properties which are important. One is its surface temperature and another is size of a star. So now how one can measure the temperature of a star. So let's look one of the way to do it. So one of the way is to find out the temperature of star is to assume that star is a black body radiator. For a radiator emitting radiation in all wavelengths from 0 to infinity. So if body is a black body, then curve comes like this. So where we can see this band which is visible here, it's written like visible. So where only a part of this whole curve, only a part of this curve lies in this visible portion of electromagnetic spectrum. If one looks for such kind of a curve for our own sun as black body radiator, peak of this solar radiation lies in intermediate region of visible range. That is why sun appears yellow to us. If this curve is then fitted to a black body spectrum which peaks in yellow light, it happens for a black body of surface temperature of about 5800 Kelvin. So hence one can infer that surface temperature of sun is around 5800 Kelvin. So amount of intensity observed that at different wavelengths is plotted and fitted to a black body spectrum to know the temperature of sun or any other star. Now we come to HR diagram. Now we know the brightness, so the distance of a star using distance modulus. We also know the color, which we can use to find out the temperature. This is the plot we call as HR diagram in two different scales. Like left one, you can see there it is a magnitude versus color diagram, and in the right one it is luminosity versus temperature scale. So if one looks at this diagram, most of the stars lie in the middle region. So this region known as adulthood of stars, the time spent in this region is known as main sequence. It's the time when star is in hydrodynamic equilibrium and the inward gravitational pull balanced by the radiation pressure due to nuclear fusion at core. So now color, which is plotted in x-axis, is the difference in brightness in two different filters. Luminosity is related to surface temperature as its fourth power. If we wish to see sun in HR diagram, you can see here right in middle of the diagram, sun is here. So we can see it is a main sequence star. That is why we do not see much variation in sun's, if we say, electromagnetic output. The time spent in main sequence is the part of the life of a star when star is most stable. Star stays here for a long time with stable brightness, which is actually essential for evolution of evolution of humankind, we can say. So we also see some of the stars in upper right side this branch. The stars are called supergiants. These are the stars which basically have same or similar temperature as sun, but they have higher brightness. As luminosity is also proportional to square of radius of a star, so they are brighter because they have larger R values. They are bigger in sizes. Therefore, these stars are much brighter than main sequence star of same temperature. In contrast, there are dwarf in left lower panel. They have higher temperature, but they lose their luminosity. They are less luminous because of smaller radii, because of smaller R values they have. So they are called dwarfs. Further, there are luminosity classes, which basically depend on sizes of stars. The brightest stars are supergiants, then giants, main sequence stars, and dwarfs. Brighter stars lie upward because their radii are larger, they are brighter, and they have negative magnitude. Since magnitude scales are reverse scales, the stars with negative magnitudes are actually brighter comparatively. So stars are also divided into their spectral classes, like we saw in last diagram. Depending on their heat output, it depends on their temperature. They are defined as this O, B, A, F, G, K, and M. Typically, a O-type star is a very hot star, while M-type star is a very cold star. And in upper right, a very large, they are giants, and lower left in this diagram, in lower left, they are dwarfs. So now another important property, if one wishes to calculate the mass of a star, so it's very difficult to measure the mass of a star. Usually it can be done for binary stars, which is the two-body system orbiting each other. So by knowing the time period of revolution of stars around each other, masses can be measured. And even for main sequence stars, which are situated on main sequence, there exists something called mass luminosity relationship, which relates mass and luminosity of different stars situated at main sequence. So we can see that mass of star increases as luminosity, then luminosity of star also increases. So if one can observe the luminosity, masses of stars for a main sequence star can also be known. So this is how the HR diagram it actually summarizes some of the important properties of stars, and it gives it is known as a very important tool for astronomers, as in just one diagram we can see various different properties of stars, and even we can also look for different stages of its evolution. So with this, I will end up my talk here, and I will be very happy if some queries are there. So thank you so much.
Thank you, ma'am, for your very good speech on the topic Understanding the Stars, HR diagram. Now, after this informative keynote speech, I would like to request participants, if you have any question, any doubt, please come with it. Please, participants.
Sir, good evening. Dr. Shukla here.
Yes.
Hello. Am I audible? Ma'am, what are the chances of life because of star in other galaxies?
If you will talk in terms of probability, so we are always hopeful that we can find life somewhere else. But as far as I know, that we have not found it.
Can we find out probability with more physics?
Yeah, that we can do.
Yes. Okay, thank you, ma'am.
Anybody else with any more question, please? I request participants, if you have any question, doubt, or suggestion, please come forward.
Ma'am, I want to ask another question.
Yes.
What is the fate of a star?
What is?
Fate. How it goes and how it grows. It has life.
Yeah.
So how it and what
Yeah.
happens at the end?
Yeah, no. Actually, how the life of a star will go, like how it will evolve to main sequence, and after main sequence, what's going to happen afterwards, it will totally depend on its mass, its initial mass. So, like if we wish to know about our sun-like stars, which have comparable mass, which are main sequence stars and average kind of stars in middle of main sequence. They are not very heavy, they are not very lightweight, they have like comparable masses. So they have a hydrogen fusing core in just central region, and what's happening there, the hydrogen is being synthesized into helium. Like for our sun, we guess there are still 5 million years more, that it has a sufficient amount of fuel inside, sufficient amount of hydrogen inside, and by that time, all of this hydrogen, once means there would be certain time that all of this fuel will went over this hydrogen. All of hydrogen will be converted into helium. Then what happens that if all of the fuel is like consumed, all of the hydrogen is converted into helium. Now the star will have a helium core, and it will start like shrinking. So it will have a helium core, and what is happening in a star, there are two main forces. One is gravitational force, which is an important force because stars are very massive. If you because we talk in terms of solar masses, but if one asks that what is the mass of sun actually, so it is in I think somewhat like 2 multiplied by 10 raised to power 30 kgs. So it's of that order. So 10 raised to power 30 kgs means gravitational force is also is very dominating force. So gravitational force is there, and then nuclear fusion is going on. So radiation pressure due to this nuclear fusion is there. So when I coined a term in my talk, I said that when star is in main sequence, it is in hydrodynamic equilibrium. So what we mean by hydrodynamic equilibrium is that this gravitational pull due to mass of a star is exactly balanced by nuclear fusion, radiation pressure due to nuclear fusion at core. So when this hydrogen will all burned out into helium, what will happen? Gravity will start dominating over radiation pressure. So star will start collapsing. So when star will continuously collapse under gravity, what happens that this internal temperature of star, this starts to increase and it ignites the shell of hydrogen burning around inner core. So meanwhile, helium core continues to contract and increase in temperature, which leads to an explosion. So in lower kind of what we call that stage of star is called red giant star. So that is one of the phase of evolution. Then it will depend on mass that further it will convert in white dwarf, or if it is a more massive, there may be a supernova explosion. It can be converted into a neutron star or black hole.
Thank you, ma'am. So the life of every star is different. It is not uniform.
Yeah. Life of every star is different.
Thank you, ma'am.
Anybody else, please? The keynote speech was very good, and after that, some of the questions have been asked by the active participant. Answers have been given by the honorable speaker. So knowledge is added to us. And so after this keynote speech and question answer session, now I request the chief organizer and chairperson of this webinar series, Honorable Principal Dr. M.M. Bedkar sir, to deliver his concluding words. Please sir, welcome.
Thank you, Professor Karad sir, and all the organizing committee members, including Vice Principal A.D. Misal sir, IQC Coordinator Sanjay Kale sir, Dr. K.N. Kadam sir, Dr. Anil Wadkar sir, Dr. Dayanand Patwari sir, Prashant Ughadi sir, both the supervisors, Praveen Udge sir, Karanje sir, and all the senior members of our college, including Professor K.N. Kadam sir, Jamuntrao Kadam sir. Today's resource person, Rashmi madam, she is from physics, and the topic was related to astrophysics and about the stars. Last year there was a webinar with the topic of the garbage in the space. We are sending so many satellites and they are revolving around the earth. So that was, we were thinking that it was the topic related to space, but now today's topic was related to stars. So our journey of webinar is from stars to the bottom of the sky, means every topic was covered. Today's topic you made very simple. What about the life of the star, what is the temperature of the star, how HR diagrams are used to find out the different properties of the stars, which mathematical relations are useful for find out the properties of the stars. So there was a teacher Sharma from our university. He was saying that just at the time of refresher course, when I was attending, he is from astrophysics of our university. He said one sentence in his speech, first a sentence or a sentence in the speech. He was saying that one book is sufficient to make mad astrophysics. Means one book of astrophysics is sufficient to make mad to a man. Means if you go thinking about the sky, stars, their distances, temperature, mass, properties, life, all these things, means when we reach toward that level, so that is beyond our human imagination. The scientists finding out more and more properties about that. Just today's participant said that if there is possibility of life, so scientists are starting to find out all these useful things for us to have a human well or any so today's topic, you made simple, and you did a journey with us with the stars, and you give the more knowledge to our participants, because our participants are 99% not from physics, all are from arts, commerce, science, all these branches, economics, all these things, but you made easy to know about the stars, to know more about the illumination or that distances, all these things. And best way you started with the poem of the Harivansh Rai Bachchan. So especially physics teachers are not related to literature, but you started very impressively, and we like all these things. Thank you, madam. In future also, if you made more simple for us these terms in your own language, we will appreciate again you for this topic which is beyond our normal man's imagination. Thank you, madam. Thank you for joining here.
Thank you so much, sir.
On behalf of Shri Kumarswami College Ausa, I am here to present vote of thanks. First of all, I would like to thank today's honorable keynote speaker, Rashmi ma'am, who has accepted the invitation of our college and graced us with a very good speech on the topic Understanding the Stars and HR Diagram. The topic was simplified and it was narrated in such a way that all of us, though from different faculties, understood it very well. And after that, there was a very good question answer session. So on behalf of the organizing committee of Shri Kumarswami College Ausa, I sincerely thank you, ma'am, for a very good keynote speech. I also thank the chief organizer and chairperson of this webinar series, Honorable Principal Dr. M. Ambedkar sir, for his concluding words and for his opinion and appreciation of the keynote speech by the honorable speaker. And as we know very well that the chief organizer works hard to run this webinar series, and we had and we will have different topics related with various fields which we can enjoy and also can discuss on it only because of the efforts of the chief organizer and chairperson of this webinar series. So I thank you, sir. I also thank participants. Participants is the very significant part of this webinar series, integral part of this webinar series, and because of whom the webinar series has become successful, because of their punctual attendance, because of their patient listening and active participation in every session of this webinar series. So thank you, participants. And I thank Dr. Anita Dhole ma'am, who has given very good introduction of today's honorable speaker. And now I request participants, please fill feedback link so that you can have your certificate. And at the end, with the permission of chief organizer and chairperson of this webinar series, I announce here that today's webinar is over. Thanks to all. Thank you very much.
Thank you.
Thank you, madam. Thank you.